morning, everyone. I'm just making some tea. Welcome to my kitchen, at home chemistry in Miss Burley's kitchen today. Um, and I was just putting sugar in my tea. Have you ever noticed that when you put sugar in a drink, whether it's coffee or tea, that by the time you drink the whole thing, um, you're not drinking solids. You're drinking just like a more sugary liquid. Isn't it interesting how a solid can just turn into a liquid? Well, in this next unit, we're going to be talking about how and why things dissolve, and what makes things mix, and what makes things become solutions. And the name of this unit is solutions. Now, the word solution might sound familiar because in biology you talked about it as well. You might remember hearing that water is a universal solvent. Well, there are two parts to a solution. There's a solute and a solvent, and water is a universal solvent. It's something that we use the most to dissolve things. There are a couple other things such as different alcohols, or mercury is a solvent, and then also some petroleums can be solvents as well. But in this unit, we're really just going to be talking about water as a solvent. Now, the two parts, solute and solvent, the solute is the thing that dissolves, and then the solvent is what makes it dissolve. So in this circumstance, when I put sugar in my tea, the sugar was the solute, and then the water was my solvent. Alrighty? Now, why do they mix in the first place? Well, it has everything to do with the attraction between molecules. So, if the molecules of water feel attraction toward whatever I put into the water, then it's going to break apart those things. In this circumstance, sugar is a polar covalent compound. And if you remember from the last unit, water is also a polar covalent compound. So the partially negative ends of water are feeling attraction toward the partially positive ends of the sugar. Now, something that's really interesting is when things don't mix, they kind of look cool, especially if they're two liquids. So I actually have here some water, and then something I know that doesn't mix in water. So I'm going to get that ready right now. So here, I put some olive oil in water, and you can actually see that it's separated. The olive oil is sitting on the top, and then the water is at the bottom. Now, why does this happen? When sugar dissolves in water and salt can dissolve in water, why does oil not dissolve in water? Well, a term or a little phrase that we like to say is that like dissolves like. So if you have molecules that are like each other in terms of their polarity, then they'll dissolve in each other. So water is polar. The fact that this oil is staying separate from it must mean that it's nonpolar. So why isn't there an attraction between polar and nonpolar molecules then? So water in the bottom of this container has a dipole-dipole attraction with other water molecules, which is an attraction toward the partially positive side of a water molecule and then the partially negative side of another water molecule. Oil is nonpolar, which means it undergoes London dispersion forces. But the fact that these are all nonpolar molecules, they only form temporary dipoles. So the dipole-dipole attraction, the permanent dipole that water has, because it's permanent, the water is more attracted to molecules of the same type, and it just kind of like ignores this nonpolar compound, and therefore it stays separate. Now, the next thing is ionic compounds. So ionic compounds are sometimes able to be dissolved in water, and then sometimes they don't dissolve in water. Now, when they dissolve, the partially positive sides of water feel attraction toward negative ions in an ionic compound. then the partially negative sides of water feel an attraction toward the positive ions in an ionic compound, and it ends up separating them. Next, I'm going to have you guys watch an animation representing how ions dissociate or dissolve in water. But first, I am going to go over just a couple words because I'm going to be using them throughout the unit. First off, you just heard solute and solvent. A solute is the thing that is dissolved, so like sugar or salt. And then the solvent is what it is dissolved into, okay, or what does the dissolving, I guess. And it's present in the greater amount. And a solvent would be water. If something is soluble, that means that it dissolves. If something is insoluble, that means that it does not dissolve. The last words I'm going to use is miscible versus immiscible. So that is what we use for liquids. And if liquids are miscible in each other, then you won't see a difference throughout the whole entire liquid. It just looks like one big homogeneous solution. But if something is immiscible, this would be an example of immiscible. If something's immiscible, it means that the two liquids remain separate and they do not dissolve in one another. So now you guys should go watch the animation of how ions dissociate or dissolve in water.